Alright, so up until this point we've been talking about sequences, so number patterns. A series is just taking all of the terms in a sequence and finding the sum, so the addition. So for example, if we had the sequence 2, 4, 6, the series would look like this. 2 plus 4 plus 6. And we can actually quantify the sum of the terms in a series. So 2 plus 4 is 6, plus 6 is 12. That's the sum of the series. So just like we had two different types of sequences that we looked at, we had arithmetic and geometric, we also have two different types of series. We have arithmetic series and geometric series. In order to find the sum of an arithmetic series, SN, that means sum, we have two formulas. One of them we use if we know the value of the last term, and I think this will become more clear as we go on. The other one we use if we know the term number of the last term. So for example, if we were looking for the sum of the first 20 terms, we know the term number of the last term is going to be 20. So in the first, I guess in both formulas, we have a set of variables that we need to know. Sn is the sum, n is the number of terms that we're looking at, u1, just like it was before, is the first term. Un is always going to be the value of the last term when we're looking at sum of a series. And d is our common difference. So some of these look familiar. The only new one is Sn, and that's the sum of the first n terms. So it could be the sum of the first 5 terms, 6 terms, first 10 terms, whatever works there, whatever the question is asking you for. So let's look at this first example 1. An arithmetic series has 7 terms. The first term is 5 and the last term is 53. Find the sum of the series. So let's write down what we know. It has 7 terms, which means that n is going to equal 7, the number of terms. The first term is 5. So u1 is going to equal 5, and the last term is 53. So u7, the value of the last term, the 7th term, is 53. So if we look at this question, we know the number of terms, we know the value of the first term, and we know the value of the last term. So if I'm looking at which formula to use, we use this one if we know the term number of the last term. Well, we do know the term number of the last term is 7. And we use this one if we know the value of the last term. And we do know that. The value of the last term is 53. You could choose either. I would probably pick the simpler of the two. So Sn, the sum of the first n terms, is going to equal the number of terms divided by 2 times u1 plus the value of the last term. So inserting our own variables in there, we've got the sum of the first 7 terms is equal to the number of terms, 7, divided by 2, times u1, which is 5, plus the value of the 7th term, which is 53. So I end up with 7 over 2 times 5 plus 53, which is 58. And the sum of the first 7 terms is 203. So if we expanded that series out, even though we don't know all the terms in it, if we expanded that out, the first 7 terms, and we added them together, then we'd end up with a sum of 203. All right, let's look at example 2. So we're given a series in this instance. I know it's a series because there's a plus sign. That's what differentiates a series from a sequence. Sequences have commas between the terms. So series have plus signs between the terms. Sequences have commas. All right, so I have 5 plus 8 plus 11 plus 14 plus all the way to 101. So this is going to be the value of my last term. So if I look at the information that I have here, I know U1, the first term, is going to be 5. I know the value of the last term, UN, is 101. I think the common difference is 3. 5 plus 3 gives me 8. 8 plus 3 gives me 11. 11 plus 3 gives me 14. So my common difference is 3. So let's check back to my original formula here and see which one might work. So I don't know the sum of the first n terms. That's what I'm looking for. So I'm looking for Sn. I also don't know the number of terms, n. And I think I'm going to need that for either one of these formulas. You can see that n shows up here and it shows up there. So I need to know n. I need to know what term number 101 is. So my first step here is to find n. So I need to find the term number of 101. And that's a skill we learned back in our sequences section when we were still working with commas. And back in our sequences section, we talked a lot about the general term formula. UN equals U1 plus n minus 1 times d. I think we have enough information here to set up a general term formula, and we should be able to solve for n. So my general term formula is going to look like this. UN equals U1, 5, plus n minus 1 times the common difference, which is 3. Distributing that 3 and cleaning things up a little bit, I end up with 5 plus 3n, subtract 3. 3n plus 2 is my general term formula. I can use that to find the term number of 101. So I'm going to substitute 101 in for UN and solve for n. So I'm going to subtract 2, I end up with 99 equals 3n, divide by 3. My term number for 101 is 33, which means 101 is the 33rd term. Now that I know that, I can find the sum. So I'm looking for S33, the sum of the first 33 terms. So S33 can be found by using one of these formulas up here. And I could choose either one there, but I know the value of the last term is 101. So I think I'm going to choose the first one. N over 2, so 33 over 2 onto U1 plus UN. So onto 5 plus my last term, which is 101. So I end up with 33 over 2 times 106, which gives me a sum of 1,749.